Okay, welcome. So some of you in Year 9 are keen to try out a little unit on reactions and energy. So what do you need to know? Well, reactions tend to form into two big groups. We call them endothermic and exothermic. So those that tend to break bonds tend to require energy to do it. So that makes them endothermic. They take in energy to make that happen. And those that tend to make bonds tend to release energy as they do so. So they're making a new product and there's excess energy because they've rearranged the way things are joined together. And so we have a release of energy. And you find in most chemical reactions, you've got a bit of both endothermic and exothermic going on. So it's a way of tracking where energy is going. So of course, chemical energy is the stuff that's really driving everything. You know, it's how atoms join together to form new compounds. It's how we get energy out of old compounds to power our electricity systems, our cars, all that sort of stuff. So you're looking into this little unit now, looking at this idea of chemical energy and how it operates. With every chemical reaction, there's generally a level of activation energy that needs to be found. So you need a certain amount of energy for the equation, the reaction to occur. So you light your gas oven, you light a heater, you set fire to some fuel. It all needs a certain amount of energy to get the thing started. Anyone who's ever tried to start an open fire, it can be quite difficult until you get enough energy going. And it's always different for every experiment, for every reaction. We obviously use lots of hydrocarbons for our fuels. We use hydrocarbons in our cooking, in our heating, in our cars and trucks and buses and all that sort of stuff. We also burn hydrocarbons to create electricity. So it's a really important fuel source for us. And a lot of the hydrocarbons are based on this idea of the ethane. So methane is CH4, so 1 carbon, 4 hydrogens. And then you have a range of them. So propane, you would have maybe heard of propane, has 3 carbons and 8 hydrogens. And butane, another gas you'd be aware of probably using when you're camping, will use 4 carbons and 10 hydrogens. So these are variations on the hydrocarbon structure. Corrosion's also a chemical reaction. So the metals we dig up, so you dig up iron ore, so it's iron basically bonded with oxygen and a few impurities. You dig it up and you smelt it and remove the impurities and have just iron, and we create steel and all that sort of stuff. However, that steel, whatever you've made, will start to react with the atmosphere and start to corrode, to rust away. So this is another reaction that's always taking place. It's always out there. One of the big concerns in energy production is when we get incomplete combustion. You get some energy, but you often get toxic fumes. You get a whole lot of stuff that's, you haven't burnt stuff efficiently. You've actually lost potential energy. So an incomplete combustion is something we don't want. And when we're burning carbon dioxide, for instance, you often get carbon monoxide. When you're burning hydrocarbons, you often get carbon monoxide. And that's quite toxic. It kills humans and other animals. But of course, it also means you haven't got all the energy out of the carbon you had present. So it's an incomplete and inefficient system. So there's a little bit of background to get you started. You've got some lessons on style that dig into those ideas, that theory a bit deeper. There's some practical experiments for you to perform if you wish to. If you do wish to, let me know. I need to organise that with Parry, make sure we've got the equipment in advance. A couple of days in advance is always important. And you're going to investigate this idea of how reactions and energy can be used to fuel our systems. Using that knowledge then to explain how do we use that knowledge to explain some of our problems and issues that we face. So, the obvious one is, how do we produce energy for our future use without using hydrocarbons and producing CO2 and methane and destroying the environment, creating climate change? That could be a really interesting area of exploration, or not. It's up to you. How do you make a car engine more efficient? So it gets all the energy it can out of it, and then maybe doesn't produce as much in the way of toxic materials. Might be another interesting investigation. You'll then need to share what you've discovered with the class. And again, that sharing can be talking to the class in the front with a PowerPoint, or you might like to make a video, you might create a poster, all the usual sorts of things. Remember, list those references. They might be style sheets, that's okay, but you've got the information from somewhere. It's always good to list where you've got it from. I'll see you back in class.